Algebra 1 class. Let's start in on lesson 3-4 today. It won't be too long of a lesson. We're going to talk about using graphs and tables, primarily graphs, to solve systems of equations. There's going to be a couple different ways that we do this. We've started off last class period with doing a little activity to kind of introduce you to the idea of systems of equations. You've seen it briefly, maybe in 8th grade math, but we're going to get into it a little bit more here. So starting right up, a system of linear equations is simply a set of two or more. Okay, let's go blue here. A set of two or more equations. And specifically, those are linear equations that are going to have common variables. Okay? So a system of linear equations simply means that they have common variables, meaning they'll have an x and a y in both of those equations, in those two or more. Now, a solution to a system specifically is the ordered pair, and we know an ordered pair has an x and a y value, and it is that ordered pair that satisfies every single one of the equations in the system. Okay? Specifically in a linear system, it is where the lines intersect. So in our activity, remember, we were looking for where the other three lines intersected with our one path that we drew originally, if you remember from the activity we did in class. So to solve these, we'll get started. Solve by graphing first. Let's say we wanted to solve the following system. So we've got these two linear equations right here. One having been written in standard form, right? The other being written in slope-intercept form. Doesn't matter, we simply need to be able to graph the lines. So this one is in standard form, and both of my coefficients go in evenly to my 8. So the easiest way to go about this would be to find my two intercepts. So I would plug in 0 for y. Whoops. Let's plug in 0 for y first. So 2x plus 0 equals 8. Well, I know 2x would equal 8, which means that x would equal, whoops, miswrote that. I said 8, but I didn't write 8, did I? So 2x equaled 8, and then x would equal 4 there. So there is my x-intercept. I can go graph that right now if I wanted to. 1, 2, 3, 4. So let's find our y-intercept. For that, I'll plug in 0 for x. Okay. So 2 times 0 plus y would equal 8. So 0 plus y equals 8. So y equals 8. So I know I need to go up 8 to graph that one. I should have made these red, shouldn't I? Since my original equation was in red. So 1, 2, 3, 4, 5, 6, 7, 8. There's my y-intercept. So now I'll go graph the line. Alright, we'll guess it to be about right in there. That's not quite good enough there. Let's try that one. That's not bad. Alright, we'll go with that. Now on my other one here, do this one in blue. I don't have to rewrite this one at all. I notice that my y-intercept is -5. So I go graph that. 1, 2, 3, 4, 5. And I notice that my slope is 3/5. So I would go up 3, 1, 2, 3, and over 5, which puts me about right there. Luckily enough, that appears to have fallen on that line. So now when I go graph, the line, there we go. I look for the intersection point, okay, because that is my solution. It is the ordered pair, okay, where the lines intersect. So I'm going to look at this, and I want to be pretty accurate when I graph these. I'll look at these, and I'm going to go check the value of, let's see, I went 1, 2, 3, 4, 5, and I went down 2. So that is at 5, -2. Okay. So let's check 5, -2 in the original equations. That's what I'll do here. So this original equation, 2x plus y equals 8, I'll plug in 5 and -2 for x and y. So do that in red. 2 times 5, then it would be -2, and that should equal 8 if this is correct. So 2 times 5 is 10, -2 equals 8. So 8 does in fact equal 8. Good. Plug it into this other one over here. So y was -2, equals 3/5 times x equaled 5 minus 5. So simplify the right hand side of the equation. 3/5 times 5, the 5's would simplify to 1s. I'd just be left with 3 minus 5. -2, 3 minus 5 is -2. Since both of these are in fact equal, and they are true, then I know that my solution is in fact 5, -2, and that is my actual answer. Okay, so when you're graphing, it's important to go ahead and check it, because as we know, our graphs can sometimes be a little off. So we'll want to make sure that we check those answers algebraically by plugging them in to the original problem. Okay, now moving on, we're going to go over the different types of solutions that we can have as it pertains to these linear systems of equations. The first, as we can see, we have two different lines here. The slopes of these lines are different, you'll notice. Let's write in blue. So the slopes of these lines are different. Therefore, the lines intersect. Now, think about this. Can these lines intersect more than one time, ever? If you give that a little thought, your answer should be no. Therefore, if this is the case, where the slopes are different, then we will always only have one solution. Now, in the second case here, we've got lines where the slopes appear to be the same. Okay. However, the y-intercepts of these two lines are in fact different. So what can we say about those lines? Those lines are parallel. So will those two lines ever intersect? That answer would be no. Therefore, there will be no solution to those two, to the linear system of equations. Our last example, you may not be able to see on your paper, but you should be able to tell here on the video. I've got a line that's green here and a line that's blue. I made one large so they would show up and not cover up. The slopes and the y-intercepts are both the same. Okay, the slope of the green one and blue one is the same. The y-intercept of the green one and the blue one is the same. Therefore, these are the same line. Okay, what this means is that there's not just one intersection point. All of these points are intersections of these two equations, or these two lines. Therefore, we would have infinitely many solutions to this. So that's how you would tell by looking at the graphs. And what I'm going to do now is show you a quick video so we can get just make sure we've got a good handle on this, okay? So page 2, number 4. Whoops. I was going to show you this video too.
Let's look at this first system of equations. If we graph these two lines, we can see that they are parallel. The slopes are the same, but the y-intercepts are different. These lines will never intersect, so there is no solution to this system of equations. There is no ordered pair that satisfies both equations. Now, let's solve the next system of equations. We can graph the first line, but need to use intercepts to graph the second. The x-intercept is -8, 0, and the y-intercept is 0, 2. Plotting these intercepts, we can see that these equations are actually the same line. So any point on this line is a solution to this system of equations. Therefore, this system has infinitely many solutions. You've already learned that if two lines intersect, there is one solution. Now we've seen that if two lines are parallel, the system has no solution. Also, if the equations represent the same line, then there are infinitely many solutions to the system.
Okay, so we'll look real quick here. Just looking at these, you should be able to tell these are parallel lines and would have no solution. Looking at these, they are going to intersect once and only once. And looking down here, we've got two lines that appear to be the same, so we would have infinitely many solutions. Okay, so pretty easy concept to see visually. What you need to be able to do, though, is to also see it algebraically as it pertains to different equations here. So that's what we're going to look at right now. We're going to determine whether the system has none, one, or infinitely many solutions, not by looking at the graph, but by looking at the equations. Well, there are two things that are going to tell you whether they're going to have none, one, or infinitely many, and that is their slope and their y-intercept. Okay? So, and we compared all those up here in our notes. So now we're going to actually do it algebraically. To determine whether something has none, one, or infinitely many solutions, we're going to want to first put everything in slope-intercept form, because that'll make it easiest to compare the slope and to compare the intercept. Okay, so in order to do that, first thing I need to do is solve for y, right? So I need to move my 2x over. So I have 3y equals 2x minus 6. I just added 2x to both sides. Now I need to divide everything by 3, and I would get y equals 2/3 x minus 2. Go do the second one. I'd move my 4x over. Negative 6y equals negative 4x minus 6. And then I'm going to divide by negative 6, so I would end up with y equals negative 4 over negative 6 is going to be a positive 2/3. Negative 6 over negative 6 would be a positive 1. Okay, so now I'm going to compare my slopes and my y-intercepts. My slopes are the same. Okay. Whoops, the same. My y-intercepts are different. Well, what does that say about those? They're going to be going the same way. They've got the same slope, but they're at different locations. So that matches this one right here, right? These two lines are going to be parallel, therefore there will be no solution. Okay? Moving on to this next set here. Y equals 4x minus 3, that's already in slope-intercept form. So we don't have to do anything here. Let's move over to the next one and rewrite this. So I'd have negative y equals negative 3x plus 4. I want to solve for y though, not negative y, so I need to divide or multiply, whatever you want to think about it as, dividing by negative 1. Or just change all the signs, right? So that would be 3x minus 4. And in this one, my slopes are different. My y-intercepts are different. Therefore, those are going to be a set of lines that will intersect only once. Okay. Now for this last one, first things first, write it in slope-intercept form. So all I need to do is distribute this negative 2 through, right? So negative 2x, negative 2 times negative 2 would be positive 4. Done there. Now 2x plus y equals 4, that's standard form. To write it in slope-intercept form, all I need to do is move the 2x by subtracting, plus 4. It appears that my slopes are the same. My y-intercepts are the same. Therefore, these are the same line, meaning I will have infinitely many solutions. Okay. That gives you a complete breakdown, pretty much complete breakdown of solving graphically. I'm going to use a video and a problem from the website to kind of go over the using of tables to figure out the solution to these systems of equations too. So let's click over and look at that. Be on page 4 in the video and number 17. So let's click on the page 4. By tables we mean these things right here, x and y values that satisfy each linear equation. So let's look at this here.
Find the solution of this system of equations represented by two tables. Since we cannot see the solution yet, we need to extend the pattern to find values that are the same. In the first table, we can see that while the x values are increasing by 1, the y values are increasing by 2. We can extend the x values by adding 1 each time. And we can extend the y values by adding 2 each time. We can always add more rows if needed. Now, for the second table, the x values are increasing by 2, while the y values are decreasing by 3. Extend this table, and we see that the ordered pair, 4, 10, is the same in both tables. So the solution to this system is the ordered pair, 4, 10.
Okay. So we see kind of how to do that too. The answer might not always be obvious. We might actually have to extend that table in order to find the ordered pairs that work. So when we use these scroll bars here I've got a problem. We would use those to find the solution. I don't know that I see anything right away. As we scroll down, what are we looking for? We're looking for a matching pair, right? So as we do that, we can kind of match up. 9, the 8s don't match, the 7s don't match, 6s, 5s, Nothing seems to match there from 1 through 10. If I scroll up here, whoops, does anything match here? Doesn't appear that anything matches here either, not even with the 0. So it looks like that one would have no solution there, okay, that we can see. Now, we could keep going one direction or another and see if those in fact converge, okay. But we'll take a look at some of those in class. We'll put them on the video here, okay. So we're all wrapped up with this. When you come back in, we'll probably do another short activity on solutions by graphing, and you will work on your practice problems. Have a good day.